Hello, I'm Paul Wilson and I'm here with my colleague David Clement. We are the engineers in control. This is the 8th talk in our series, Control Systems 101. In talk number 8, I am going to introduce the concept of a transfer function and show you how simple it is to convert a differential equation into an algebraic function in S. As we saw in talks 4, 5 and 6, we created differential equations for dynamic processes. Then in talk number 7, we met complex variables and the variable S, which is complex frequency. Now the first person who converted a differential equation into an algebraic equation was Oliver Heaviside, and I am going to show you Heaviside's method, which he called the operator calculus. Heaviside's operator he called by the letter P. At high school in England, when I was studying mathematics and physics, when I was 17, I was taught the same technique, and we used the uppercase D called the D operator. But we control engineers use the lowercase s, and it would be a gracious act if we could also call it the Heaviside operator. Let us start with a simple second order differential equation like this. d2x by dt squared plus 3 dx by dt plus 5x equals 0. All we do is we simply substitute s squared for this, s for that, a 1 for that. Alright, so substitute s squared, s to the power 1, s to the power 0, which is 1, and what we end up with s squared plus 3s plus 5 equals 0. And that is Oliver Heaviside's simple substitution. Now let's add an input and an output. So we have the output multiplied by s squared plus 3s plus 5 equals the input, and that is a simple input-output equation in S. Job done. Isn't it incredibly easy? And that's all there is to it. Now let's turn that into a transfer function. So I've got, let's write that again, so I've got output multiplied by s squared plus 3s plus 5 equals the input. Right, here's our transfer function. Transfer function in there, and so what we do is we convert that equation here into output equals input divided by s squared plus 3s plus 5, so equals input 1 over s squared plus 3s plus 5, and so this is the way it works. Translate that into a transfer function. Input, output 1 over s squared plus 3s plus 5, and there's our transfer function. So we have used a very simple method of converting a differential equation into an equation in S and then into a transfer function. For control systems engineers, we are used to working directly in transfer functions. On my part, and I'm talking about a career of 50 years or more, I have never used differential equations for real control system problems. I always go from the process dynamics straight to the transfer functions, and it becomes very easy with practice. A few years ago, a boss of mine introduced me and said, "This is Paul, he solves differential equations in his head." Well, that's not quite true. I actually solve transfer function problems in my head. And that's how easy it becomes. You can just do it in your head sometimes. So that is the end of talk number 8. Thank you for listening, and I hope you will join us again in talk number 9. The engineers in control are Dr. Paul Wilson and David Clement. You can find out more about us at www.engineersincontrol.com. Unless explicitly stated, all content in this video is original and is copyright 2022 by Dr. Paul Wilson and David Clement. All rights reserved.